In this lesson, we're going to look at method 2 for simplifying complex fractions. Now remember, in the previous lesson we looked at method 1, and so method 1 was where we had to rewrite the numerator as one single fraction, and we had to rewrite the denominator as a single fraction. And so there was some work that we had to do here in method 1 to get this to this point. All right, and then once we got it to this point, then we changed this to a multiplication problem. So we said the numerator times the reciprocal of the denominator, and we went from there. All right, so that was method 1. Now this is method 2. So method 2 involves a different process. And so on the problems on a worksheet, if it says method 1, you got to make sure you use method 1 if it says method 1. If it says method 2, then you have to use method 2. If it doesn't say anything about any methods, then you have a choice, either 1 or 2. It's up to you, but it's very important. The more tools you have, the better you become at dealing with these types of algebraic problems. So know both methods. Don't just concentrate on one or the other. Know both. It does help you. Okay, so let's talk about method 2. So method 2 is where you're going to find the least common denominator of all the fractions in the numerator and all the fractions in the denominator. And then you're going to multiply the numerator. Step 2 is where you're going to multiply each term in the numerator and each term in the denominator by the LCD. And then you're going to simplify. All right, now let me just remind you about what we talked about in method 1 in terms of what a complex rational expression is, or a complex fraction. So remember, a complex fraction looks like this. So that's where you have a numerator or denominator or both that contains fractions. All right, so these are examples. And remember, in the end, you always want to make sure that your final answer is in simplest form. So if you can factor, you got to make sure you do that. So that's where you would divide out your common factors. All right, so you want to make sure that's in simplest form. So in simplest form means that your fraction in the end, they have no common factors any further. Okay, so we talked about this in method 1 in the previous lesson. Okay, so let's go ahead and look at this example to get us started. So remember, the directions will probably say simplify. And so we have number 1, we have 3/4 minus 2/3 divided by 1/2 plus 3/8. Okay, now make sure you're using a correct method. So this is method 2, not method 1, method 2. So method 2 says this. I'm going to go ahead and read it out, and then I'll discuss a little bit further. So method 2 says you look at all of your denominators in both the numerator and the denominator. So you look at all the fractions, you look at all the denominators. My denominators are 4, 3, 2, and 8. Okay? So I have 4 fractions. 4, 3, 2, and 8. Is that clear? Then I got to find the LCD of all of those. So the least common denominator of 4, 3, 2, and 8 is what? So remember, you take the largest, so 8. 8 times 2 is well, 8's not the LCD, right? Because 3 doesn't go into 8 evenly. 8 times 2 is 16. 16 is not the least common denominator because 3 doesn't go into 16 evenly. But what about 24? 8 times 24. Does 4 go into 24? Yep. Does 3 go into 24? Sure. 2 goes into 24 and 8 goes into 24. So the LCD is 24. All right, so just that's what you got to do with method 2. Now, once you find your LCD, now I'm going to say this. Method 2 works easier for some problems, and method 1 works easier for some problems. But method 2, it kind of saves yourself quite a bit of this work here. So remember, we had to go off to the side and figure out all this work. So notice what happens with method 2. So now the second step, so that was step 1. So now the second step is to multiply both the numerator and the denominator by the LCD. That's the second step. So basically, here's what you're going to do. So I'm going to go ahead and rewrite this over so I can leave the original problem as it is. And watch what happens. So method 2 says this. I'm going to take the numerator, I'm going to multiply by 24. I'm going to take the denominator, multiply by 24. Okay? And then I'm going to get rid of the parentheses. I'm going to distribute. Get rid of the parentheses, distribute. So basically you're taking every term that's in the numerator, and those are two terms. You're multiplying by 24. You're taking every term in the denominator, you multiply by 24. So remember, what you do to the numerator, you do to the denominator, because you got to keep that to be a 1. So 24 divided by 1 is still, 24 divided by 24 is still 1. All right, so now you get this. You get, now actually write out these steps. You get 3/4 times 24 minus 2/3 times 24. See what that looks like? That's important you do that. Divided by, now the denominator, the fractions in the denominator, 1/2 times 24 plus 3/4 times 24. If you're doing this correctly, then all these denominators are going to end up with being factors of 1. Okay? And the reason is because you found the LCD. You found the smallest number that all those denominators will divide into. So 4 better go into 24. 4 goes into 4 one time. 4 goes into 24 6 times. You see that? 3 goes into 3 one time. 3 goes into 24 8 times. 2 goes into 2 one time. 2 divides into 24 12 times. 4 into 4 is 1. 4 into 24 is 6. All right? And so now I'm going to get 3 times 1 is 6. I'm sorry. 3 divided by 1 times 6 is 18 minus, and then notice that's a 2, right? Because 2 divided by 1 is 2. 2 times 8 is 16 divided by 1 times 12 is 12 plus 3 times 6 is 18. And we're almost done. Watch. 18 minus 16 is 2. 12 plus 18 is what? 30. So I get 1 divided by 15. So there's your answer. So that was method 2. So method 2, let's remind ourselves, method 2 says this. Method 2 says I look at all the denominators and I find the least common denominator. Once I find the least common denominator, then I'm going to multiply every term in the numerator and every term in the denominator by 24. So you can distribute, and that's what you're seeing here. So 3/4 has to be multiplied by 24. 2/3 has to be multiplied by 24. 1/2 has to be multiplied by 24. And then 3/4 has to be multiplied by 24. And then you just take each product and you simplify. Okay, you reduce. And now once you reduce, you're going to get 3 times 6 is 18 and so forth. And then you go from there. And then reduce make sure your final answer is simplified. So notice 2 divided by 30, I can reduce as 1/15. So that was number 1. All right, let's look at number 2. So in number 2, let's suppose we had this. We have 3 plus 5/6 divided by 3 plus 2/5. 2/5. Okay? So again, notice that for some students it does help. For some students it does help if you rewrite 3 as 3 divided by 1. And I'm going to go aside right here and actually do that. So 3 divided by 1 plus 5/6 divided by 3 divided by 1 plus 2/5. Okay? Now don't make the mistake and divide those 3's out, because those are not factors. 3 is part of this term. This whole thing, if you want to think as a factor, is a factor of the numerator. All right, so just be careful. You can't divide these 3's out and say that's a 1. All right, because of the addition. Remember, factors are separated by multiplication symbols. That's 3 plus, not 3 times. That's 3 plus, not 3 times, so be careful. Okay, so now we're going to look at remember this is method 2. So once I find all, so the next step is to look at all the denominators, 1, 6, 1, and 5. So remember this is step 1. So step 1 in method 2 says you find the LCD of all your fractions in the numerator and the fractions of the denominator. And then you would go from there to step 2. So notice that if I look at the denominators here, 1, 6, 1, 5, the LCD is 30. So once you find the LCD, then the next step is to multiply numerator and denominator by 30. And always use the least. See, if you said 60 or 90 or 120, and you can, that would make these numbers a lot larger to deal with. So always use the least. It makes things a lot easier for you if you use the least common denominator. Okay, so now we're going to distribute. So remember, the whole thing is this. So if you're doing this correctly, what's going to happen is that every fraction in the numerator, every term in the numerator has to be multiplied by 30. So now what you're going to have is 3 divided by 1 times 30, plus 5 divided by 6 times 30, divided by, and then move this up, and then 3 divided by 1 times 30, plus 2/5 times 30. All right, so just like this. So that process is the same idea. So once you get to that point, though, remember the whole reason of multiplying by 30, every term by 30, is to get these denominators to be a factor of 1. So notice that this is already a factor of 1, so I'm going to leave this alone for right now. But here, that's a 6. I want to get that to be a 1. And I can now, because 6 divided into 6 is 1. 6 divided into 30 is 5. So if you found your LCD correctly, then this should, when you get to this point, this should now be a factor of 1. This is already a 1. Now let's look at this one. 5 into 5 is 1. 5 into 30 is 6. And now what I'm going to do is I'm going to look at each product, and I'm going to write out what it is. So that's going to equal 3 times 30 is 90, plus 5 times 5 is 25, divided by 3 times 30 is 90, plus 2 times 6 is 12. Okay? So now this is going to be 90 plus 25 is 115. 90 plus 12 is 102. Okay? Now I've got to reduce this. I've got to simplify this. So notice that both of those are divisible by 3 at least. Nope, not by 3. So let's see. The denominator is divisible by 3, but the numerator is not, because remember, you can tell if a number is divisible by 3 by adding the digits, 5, 6, 7, and 7 is not divisible by 3. So let me just check 115. So what I'm doing is I'm taking 115, dividing by 5, and see what I get. No, that's a prime number. So that's it. It cannot be reduced. So you're good. So that's the answer, 115 divided by 102. All right, so that's number 3. All right, so and that's using method 2. So notice method 2, compare method 2. I need for you to compare method 2, the way we did this, with method 1. See the similarities and differences between the two. Okay, let's look at number 3. So number 3, all right, number 3, let's suppose we had this. 1 plus x divided by y divided by 2x plus 1 divided by y. Okay? All right, now, again, we want to use method 2. Method 2. So method 2 is where you got to look at all your fractions, the denominators of all the fractions, and then find the LCD. Okay? So notice I'm going to rewrite this as 1 divided by 1. So let me go right here and do that. 1 divided by 1 plus x divided by y, and then divided by, notice that in this denominator I only have one fraction. Okay? All right, now here's what I'm going to do. I'm going to circle all the denominators. Okay, I'm circling this, I'm circling this, and I'm circling this. Okay? So method 2 says I look at all the denominators and I find the LCD. So what's the LCD of all those 3 expressions that I have circled? Well, 1, y, and y is just y. So the LCD is just y, right? So once you find the LCD, then the next step, and I'm going to go ahead and rewrite this over since I marked on it. So it helps if you rewrite things, it doesn't make it look too cluttered. So it does help with your thinking. So now the next step is to multiply both numerator, just like this, and denominator. Now notice I'm not putting that in parentheses because it's just one fraction. And denominator by y, just like this. Okay? And so now I'm going to distribute. I'm going to get rid of this. Now remember, step 2, if you go back to step 2, in method 2, it says multiply each term in the numerator and each term in the denominator by the LCD. So notice that the numerator had two terms. The denominator had one term. Think of a term as a fraction. So one fraction, one fraction, one fraction. So when I distribute, I want you to see what's happening. I have 1 divided by 1 times y plus x divided by y times y divided by, and then this fraction, think of a term as a fraction. It does help. And then 2x plus 1 divided by y times y. Okay? Now, if you're doing this correctly, if you found the LCD correctly and you're doing this part right here correctly, then now notice this already has a 1 as a factor, so this right here better, when you reduce, better be a factor 1, and it is, because y goes into y one time, y goes into y one time. Same thing here, y goes into y one time, y goes into y one time. Okay? And so now notice what happens. Watch how easy this is now. Watch. 1 times y is y plus x times 1 is x. See that? Divided by 2x plus 1 divided by 1 times 1 is 2x plus 1. And then factor if you can, because remember, you got to simplify this. So I cannot factor anything with the numerator. The denominator, I cannot factor any further, and so there are no common factors, and so this is your answer. Okay, so method 2. That's method 2. So remember, method 2 says that you got to look at all your fractions. So I have 2 fractions up here, I have 1 down there. Find the LCD of those denominators, and then multiply every term, 1, 2, 3, 1, 2, 3, by that LCD, and then notice we reduced, and then we went from there. Okay, so that's number 3. Let's look at number 4. So number 4, we have, let's say we had this for number 4. We have 4 minus 1 divided by x divided by 3 minus 1 divided by x. Okay? So let's go ahead and rewrite this as fractions right here. 4 divided by 1. So I get 4 divided by 1 minus 1 divided by x, and that's being divided by 3 divided by 1 minus 1 divided by x. Okay? Now again, notice in the numerator I have 2 fractions. In the denominator I have 2 fractions. So think of these fractions as your terms. So 1, 2, 3, 4. So at some point, I'm going to be multiplying every term by the LCD. So it's going to always look like this at some point. Okay? So notice I'm going to circle all my denominators because step one says I got to find the LCD of all these fractions. So 1x, 1 and x, the LCD is x. So that's easy to deal with. The LCD is x. So now I'm going to take the LCD, I'm going to multiply the numerator by it, I'm going to multiply the denominator by it. Okay, so 4 over 1 minus 1 divided by x divided by 3 divided by 1 minus 1 divided by x. And so this will be times x, and this will be times x. And then I'm going to distribute. And so once you distribute, you are actually doing what step 2 says. So step 2 says you multiply each term in the numerator, each term in the denominator, so each fraction, so to speak, by the LCD. So in other words, you're going to say this term or this fraction by x times x minus 1 over x times x divided by, and then do the same thing with the denominator. 3 over 1 times x minus 1 over x times x. And then you reduce. So this already has a factor 1. This does not, so that should reduce, because remember that's the whole point of finding the LCD is to get this right here to be a factor 1. So 1 x divided by x is 1, x divided by x is 1. Same thing here. And so now all these denominators have a factor 1. So now I'm going to rewrite, I'm going to go a little bit further, I'm going to rewrite this. So 4 times x is 4x minus 1 times 1 is 1 divided by 3 times x is 3x minus 1 times 1 is 1. And then that's all you can do. You can't factor any of that, and so there are no common factors. Okay, so that was number 4. Let's look at number 5. Number 5, we have x divided by y minus y divided by x divided by x plus y divided by y. Okay? All right, so again, notice that the numerator has 2 fractions in it. The denominator has 1. Okay? So those are your terms. So 1, 2, 3. So let me go ahead and rewrite this over. And so now what we're going to do is we're going to circle all of these denominators for those 3 fractions. And so if I look at this, what's the least common denominator of those 3 expressions that I have circled? So y, x, and y. Okay, so the LCD is yx or xy, right? So remember, your LCD must include every factor you see. So notice I have a y, I put a y. Have an x, I put an x. Have a y, I already have it. So now I'm going to rewrite this again. So I have x divided by y minus y divided by x divided by x plus y divided by y. So now I'm going to multiply the numerator and the denominator by the LCD, just like that. Okay? Now notice I didn't put this in parentheses because there's just 1 fraction. Here I have 2 or more fractions up here. In this case, 2. Okay, so now I'm going to distribute. So remember, step 2 says, and that's what we're doing in step 2. So step 2 says I take every term and I multiply by the LCD. So I get x over y times xy minus this term times the LCD, y over x times xy, because remember, using distributive property. The denominator, I'm going to leave it as is for right now. So x plus y divided by y times xy. All right, now the next step is where we're going to reduce. So the whole point of multiplying every term by the LCD is to get these denominators to be a factor 1. That's the whole point. So y divided by y is 1, y divided by y is 1. Okay? X divided by x is 1, x divided by x is 1. Y divided by y is 1, y divided by y is 1. So I've reduced. So now we're almost done. So now the next step is to simplify this as much as possible. So x times 1 is x squared. See that? This product is x squared. X times 1 is x squared. Minus y times 1 times y is y squared. So that's the numerator. The denominator, I have x plus y times x. Now leave it in factored form. Remember, it's important. Remember, we talked about this before. Always leave it in factored form. Don't distribute, and you're going to see why in a little while. So x plus y times x. I'm going to put the monomial factor first. Now notice, don't stop there, because remember, the whole point next is to factor numerators and denominators so you can reduce. So you got to simplify this. So to simplify this rational expression, you have to factor and then see if they have any common factors. So notice that when we did the previous one, when I got to that point, I couldn't factor any further, and I didn't have any common factors. The same thing in number 3. I couldn't factor any further, and there were no common factors. But here I can, because look, that's the difference of 2 squares. So I can factor the difference of 2 squares as x minus y times x plus y. So that's your numerator. The denominator, see, I told you to leave it in factored form, right? So don't distribute, because you would have to factor it anyway. X times x plus y. And then notice you can simplify, because these factors of x plus y's divide out. And so you get x minus y times 1 is x minus y. And then x times 1 is x. So there's your answer. Okay? All right, so just remember, in the end, that's not your final answer, because you got to be able to simplify if you can. And so to simplify, you may need to factor, and you can factor here and then go from there. All right, so that's number 5. Let's look at number 6. So number 6, we have, again, method 2. So let's see, number 6, we have this. Maybe one with let me find one. Yeah, okay, let's do this one. We have 6 divided by y plus 7 minus 1 divided by 6 divided by y plus 7 plus 1. All right, so let's do one like that. So again, notice that the in the numerator there are 2 fractions, this fraction and this fraction. In the denominator, I'm adding these two fractions, this fraction and that fraction. Okay, so I'm going to go ahead and rewrite this whole thing so that way this has you can obviously see a denominator here. So in other words, I'm going to write this as 6 divided by y plus 7 minus 1 divided by 1 divided by 6 divided by y plus 7 minus plus 1 divided by 1. And so I'm going to circle all these denominators. And now I've got to find the LCD of all those denominators. Now notice that this is already factored. Okay, or I should say you can't factor any further, excuse me. Y plus 7 is y plus 7. All right, so let's go ahead and find the LCD of those four expressions that I have circled, those four factors. So y plus 7, 1, y plus 7, 1. Do you agree the LCD is just y plus 7, right? Okay, so now I'm going to multiply. I'm going to rewrite this over. Just go in here and rewrite this over. And you multiply both numerator and denominator by the LCD. So basically what's happening is that you're going to multiply every term by the LCD. So you're just distributing the y plus 7s. So basically you're going to say this. You're going to say this term, this fraction, times y plus 7 times the LCD minus 1. I'm going to write 1 as 1 over 1. 1 times, and be careful, put that in parentheses, times the LCD. Okay, now you could put this in parentheses as well, doesn't matter. Okay, it does not matter. If you want to put that in parentheses, you can. Divided by, and then 6 divided by y plus 7 times, again, y plus 7, plus 1 over 1 is just 1, times, in parentheses, y plus 7. Now the reason I told you to put this in parentheses because if that was a 2 or some other number, then every term in here needs to be multiplied by that number. Okay, so now let's reduce. So the y plus 7's divide out, right? Over here as well. And that's about all I can do in terms of reducing. So this becomes 6 times 1 is 6. Now distribute the negative 1. Do y'all see that this becomes minus y? A negative 1 times y is a negative y. And a negative 1 times 7 is a negative 7. Divided by, and the denominator I get 6 times 1 is 6. Now if I distribute the positive 1, 1 times y is y. And then 1 times 7 is 7. And so therefore you get, let's see, this is going to be negative y minus 1. Is that correct? In the numerator? And in the denominator, that looks like y plus 13. And that's about all you can do. You can't. You may say, well, can you factor out a negative 1 from here? Yeah, but it's not going to help because nothing's going to reduce. So if you factor out a negative 1, you're going to get negative 1 plus negative 1 times y plus 1. And then the denominator is just y plus 13. So see, you still can't reduce. So I would just leave it like that. Okay, let me do one more because I want to do one more where we have to possibly factor. So let me just try find one real quick. All right, let's just look at this one. So this is number 7. We have 8 divided by x plus 4 plus 2, and then 12 divided by x plus 4 minus 2. So it kind of is very similar to the one we just did, and there's a reason why I want to do that one. So it looks very similar to this. So again, notice that, let me go ahead and rewrite this. So I get 8 divided by x plus 4 plus 2 divided by 12 divided by x plus 4 minus 2. So notice, and this is 2 divided by 1, 2 divided by 1. So notice that if you look at all the denominators, the LCD is 4, x plus 4, right? So the LCD is x plus 4, x plus 4. So now I'm going to rewrite this again because I already marked on this. So let me just go ahead and rewrite it. And so now we're going to multiply both numerator and denominator by the LCD, x plus 4. Okay? And so now you're going to distribute. Now, remember, step 2 says, and that's what's happening when you distribute. So step 2 says you take every term, every fraction, and you multiply by the LCD. So 8 divided by x plus 4 times the LCD. Plus 2. Now remember a while ago when we did this one, I said it's important you put that in parentheses right here. And again, the reason is because this 2 has to be multiplied by every term in the LCD. So that's going to be important. So put that in parentheses, just like that. Okay? And then I just wrote 2 of 1 is just 2 because it's easier to deal with if it's just a whole number 2. Divided by, same thing here, 12 divided by x plus 4 times the LCD. And if you want to put the LCD in parentheses, you can. You didn't have to because these x plus 4s will divide out. And then minus 2, it's important that you put this in parentheses, though. That's important. Because all these have to just, remember, when at some point you can distribute, so all these will have to be multiplied by 2 in this case and by negative 2 in this case. So that's reduced. So the x plus 4 is divided out. That was the whole point of multiplying by the LCDs to get these denominators to be a factor 1. And so now I get 8 times 1 is 8. Okay, right here, this product's 8. Plus, and then if I distribute, that's going to be 2 times x plus 2x, and then 2 times 4 is 8. Divided by the denominator, that's 12 times 1 is 12. If I distribute here, I get minus 2x, and then minus 8. And so therefore I get 2x, when I combine like terms, I get 2x plus 16, divided by, and this is negative 2x plus 4, 12 and a negative 8 is 4. And then remember, the next step is to reduce if you can. So when we did the previous problem, when I simplify if you can, when I did the previous problem, when I got to this point, I couldn't simplify because I really couldn't factor the numerator and the denominator any further. And so they didn't have any common factors. So here, though, I can factor out a 2 from the numerator. So when I factor out a 2 from the numerator, I get 2 times x plus 8, right? Over here, when I factor out, I can factor out a negative 2. I get negative 2 times x plus 2. Y'all agree? I'm sorry, x minus 2, right? When I factor negative 2, because negative 2 times x is negative 2x, a negative 2 times a negative 2 is a positive 4. And then notice I can simplify these 2's. So let me go off over here and show you. Okay, so what's happening is this. So you see that both of those are divisible by 2. So you get 2 divided by 2 is 1. Negative 2 divided by 2 is a negative 1, right? Negative 1. And so the question is, how do I write the answer like that? Okay, so chances are we prefer you see how this is 1 divided by negative 1 is negative. We prefer you put the negative out in front of the fraction. So this would be the numerator is x plus 8, the denominator is x minus 2, and so you have a negative out here. So it's a negative rational expression. That's how we prefer to write it. Now, if you want to, nothing wrong with this. If you want to, you can say the numerator is 1 times x plus 8 is x plus 8. The denominator, distribute the negative 1, or you can leave it as negative 1 times x minus 2. Does not matter, but you can distribute the negative 1. X plus 8 divided by negative x plus 2. See that? Or if you want to put the negative in the numerator, that's fine. See, there's all kinds of different ways of writing that answer. But this is the more preferable right here, where you just put the negative in front. But you could put the negative 1 in the numerator if you want. So in other words, you could have, see how this looked? In other words, you can have this instead. Negative 1 times x plus 8 divided by x minus 2. Okay? And you see how when we looked at this, and you could also distribute if you want to. You can distribute this if you want to. So you could say r negative x minus 8 divided by x minus 2. So all of those are fine. Okay? But this is, so remember, we circle all the possibilities for your answer. All the possibilities for your answer. So the negative 1 factor, there are multiple ways of writing it, but it's preferable just to put the negative out in front of the fraction. All right, so that was number 7. So that's I think you have enough information there to understand what method 2 is. So that was method 2. Now, there's going to be, the next part is going to be where we're going to talk about this. So let me just kind of explain what the next part is. So you now know about method 1 and you know about method 2. So now you have you have two methods to simplifying complex fractions. So method one, this lesson was, all we did was method one. In this lesson, all we did was method two. Now, unless you're told, you can use any method you want to. So in the next lesson, what I'm going to do in the next lesson is we're going to look at some more problems and then use various methods. Some of them will use method one, some of them will use method two, and you'll see that in some situations it's easier to use one method over another. Okay, so that'll be the end of the lesson dealing with method two.